Hi everyone, I'm Sandhya, Department of Mathematics. Today we are going to see about the Fourier Transform. In this Fourier Transform, we are going to see about the Fourier Transform pair. So in this Fourier Transform pair, the Fourier Transform of f of x is given by capital F of x. So in this the Fourier Transform we denoted by the symbol is capital F of s. We use the formula 1 by root 2 pi minus infinity to infinity f of x e power isx into dx. Here you know e power I theta value is cos theta plus I sin theta. So here we use e power I theta value in the e power isx. So e power isx equal to that is cos sx plus I sin sx. So the f of x is a cos cos sx plus I sin sx. Okay, next we are going to see about the inverse Fourier transform. So inverse Fourier transform is f of x. Here we using the Fourier transform, we get the Fourier inverse. So 1 by root 2 pi minus infinity to infinity capital F of s, you know the capital F. So we want to find the capital F of s using the formula 1 by root 2 pi minus infinity to infinity f of x e power isx into d here x. Okay, so here we use integrals depends on the function. See the function, it is f of s, so we use the integral as ds. Here also we use the formula e power minus I theta. So e power minus I theta is cos theta minus I sin theta. Okay, so using the 1 and 2, that is the Fourier transform, and the inverse Fourier transform is called the Fourier transform pair. Okay, so here f of x equal to f of inverse capital F of s equal to f inverse of capital F of small f of x. Here we are going to see about the some basic problem for the Fourier transform. Okay, so find the Fourier transform of the function f of x equal to 1 0 mod x less than a and mod x greater than a. Okay, here the integral 0 to infinity sin t divided by t into dt equal to pi by 2. So here we want to reduce the part is here also given, and the f of x is given. Okay, so we want to find the first we want to find the Fourier transform. How we can find the Fourier transform using the function? Yes, it is capital F of s equal to 1 by root 2 pi minus infinity to infinity f of x e power isx into dx. In this e power is replaced by cos sx plus I sin sx into dx. Next, in this f of x is here we want to see it is 1 0. So we using 1. So the range is converted into minus a to a. Here the mod x less than a. So we going to use minus a to a cos sx into dx. So here we want to split the real and imaginary part. In this imaginary part, it is a odd function, so the answer is 0. Only we occur in the even function only. So next, if it is a even function, so we have to write the 2 times of using the property. So 2 times of 0 to a, so 2 divided by root 2 pi 0 to a cos sx into ds. Okay, next root 2 pi. Next we want to integrating cos. So integrating of cos is sin, so sin sx divided by s. Then we want to substitute the upper limit and lower limit. Upper limit is 0 and the lower limit is a. So the upper limit is root 2 by pi sin s a divided by s minus sin 0 by a. So the sin 0 is 0, you know. So the our Fourier transform is for the function 1, we get the answer is root 2 by pi sin sa by s. Next we want to find the reduction part. In this reduction part, the answer is 0 to infinity sin t divided by t into dt equal to pi by 2. So in this deduction part, we have to use the Fourier inverse formula. You know the Fourier transform value. In this Fourier inverse formula, we have to substitute the Fourier transform, we get the that reduction point. Here also we want to check it is an odd function or even function. Okay, so then we want to split in the real and imaginary part. So we only we get the even term. So 1 by pi minus infinity to infinity sin sx divided by s into cos sx into ds. Okay, so here also this is even function only. So our answer is 2 by pi 0 to infinity sin sx by s cos sx into ds. Okay, next in this 2 by pi take it into the left hand side, so it become a pi by 2 equal to 0 to infinity sin sx divided by s into cos sx into dx. Then this is the answer. So here we are going to see we can solve. It is the 0 to infinity sin t divided by t into dt equal to pi by 2. So here we want to substitute what is that here in this answer, this no need to come cos sx value. So if we remove the cos value, we have to substitute x equal to 0 and a equal to 1. So pi by 2 0 to infinity sin s divided by s into ds. So the value pi by 2, we have to replace s equal to t and ds equal to dt. So this is our answer. Okay, so here also pi by 2 equal to 0 to infinity sin t divided by t into dt. So similarly we want to prove the next one also. So find the Fourier transform f of x. Here the function is x equal to z x, and if mod x less than a, and 0 if mod x greater than n. Here similarly we want to solve Fourier transform. In this there is no deduction part is given, so we don't want to use the Fourier inverse formula. Only we want to find the Fourier transform. Okay.